Okay, everybody. Excuse me. This is a summary lesson. It's just going to go over the highlights of this week's lessons that I sent out on Monday. So, if you have a polynomial, 2x cubed plus 3x squared minus 6, and I ask for the potential zeros, that's going to be p over q. If you remember, p are the factors of the constant term. In this case, negative 6. Q are the factors of the leading coefficient, which I'm going to say LC, in this case 2. So factors of 6, plus minus 1, plus minus 2, plus minus 3, plus minus 6, over plus minus 1, plus minus 2, factors of the leading coefficient. The potential zeros are 1 over 1, 1 over 2, which is a half, 2 over 1, 2, 2 over 2, which would be 1, so you don't have to rewrite that because you already have the 1. 3 over 1, 3 over 2, 6 over 1, and then 6 over 2 is 3, which we already have. So again, that's it. Those, excuse me, are your potential zeros. If I ask for factors, that's the sort of x minus a stuff. So this is going to be, the 1 will be x plus minus 1. The 1/2 is x plus minus a half, but if we want them as integrals, so no fractions, remember that 2 can go there, and you have 2x plus 1. X plus minus 2, x plus minus 3, excuse me, x plus minus 3 over 2, which again, no fractions, so the 2 moves up, so 2x plus minus 3, and then, I'll just write right here, x plus minus 6. These are your potential factors. Alright, so definitely be aware of how to answer a question like that. Second main idea. The second main idea is finding the remainder. So what is the remainder when p of x, which is 5x to the fourth plus 2x minus 3, is divided by, oh, let's do a fraction. 2x plus 1. Okay, so the first thing you have to do is figure out if you're going to do synthetic or not. There's two ways to do this, actually. Let's figure out our a value. So you see up here, it's x minus a integrals. So essentially, what makes this 0? Because this 2x plus 1, as you can see here, is the same as x plus a half. So what makes this 0 would be our a value, and we call it x, is equal to negative a half. So, two ways to do this. You can do division. And again, like I said, I don't know, I'm going to do synthetic. It's going to be harder than I wanted it to be. So, negative 1/2 goes out here. 5. And remember, it's 4 and then goes down to a power of 1. So we need a cubic and a squared. So we add in the zeros for those, and the 2, and then the minus 3. Okay, this is going to get ugly. 5 comes down. Negative a half times 5 is negative 5 halves, or negative 2.5. We'll just do that. do it with decimals. Okay, and then 0 plus 2.5, negative 2.5 is negative 2.5. 2.5 times a half, so half of that is 1.25. Add again. Negative a half times that is negative 0.625. 2 plus that is 1.375. And a half times that is negative 0.6875. Add those together, negative 3.6875. That is your remainder. So you can do division, you can do synthetic division, or you can use the remainder theorem. We can do remainder theorem, which basically says take your a value and put it into the polynomial. So it'd be 5, negative 1/2 to the fourth, plus 2 times negative 1/2 minus 3. Negative 1/2 to the fourth is 1 over 16. 2 times negative a half is negative 1 minus 3. So I'm essentially got 5 over 16 minus 4. You go 5 divided by 16. 0.3125 minus 4 equals negative 3.6875. It's the same thing, all right? If you're just looking for the remainder, this is definitely, I think, faster and easier, but you can do the division. The division really plays into it when you are going to factor something, which is what we're going to do right now. So the main thrust of all this is how to factor a polynomial of degree greater than 2. So factor 6x cubed plus 23x squared minus 6x minus 8. All right, you should try this on your own. You can pause the video. But what I would normally do is I'm not going to test all the potential zeros. I would narrow it down. So use a is equal to 8, 4, or negative 4. Those are your choices. I've narrowed it down to 3 of them. So you have to test to see which one works. This is where you should pause it and see if you can question on your own. So if we're going to test, I'll just start with A. Do division. The reason I'm doing synthetic division, because if it is a factor, then I'm halfway there. But you could use remainder theorem like we did here. Then you're going to have to divide anyway. So I tend to use synthetic division. 6, 23, negative 6, negative 8. So 6 falls down. 6 times 8 is 48. Add those together, you're going to get 71. 8 times 71, we're getting really big numbers here. So I know it's not going to work out. So that's the remainder. Therefore, not a factor. So we test the next one. Different color. So we'll use negative 4. 6. So we do our division again. 6 falls down. 6 and 4 is negative 24. It's going to be negative 1. This is already looking better. Negative 4, negative 1, 4. That gives me negative 2. Negative 4 times negative 2 is positive 8, which gives me a remainder of 0. Therefore, x plus 4 is a factor. Okay? And it's x plus 4 because remember, that's my a value, and it's always written as x minus a. So it'd be x minus negative 4. So I get the x plus 4. And then, sorry, we always write it as dq plus r, my divisor, x plus 4. My quotient is this bit, which is going to be 6x squared minus x minus 2. And the remainder is 0, so nothing else goes there. And then we just have to factor this quadratic. So again, everybody factors differently. I go 6 times negative 2, which gives me negative 12. And I go, okay, what multiplies to negative 12 and adds to that negative 1? Negative 4 and 3. So this negative x becomes negative 4x plus 3x. Negative 2 comes down, 6x squared comes down. I bracket the first two terms and take out a 2x. Get 3x minus 2. Take out a 1 from the second set, and it stays the same. You know you're doing it right when those brackets match. You essentially factor out a 3x plus 2, or minus 2, sorry. And I'm left with 2x plus 1. X plus 4 comes down, and that is your factored form. If you multiplied all this out, you would get back to the original polynomial there. All right, that's the summary for the week. Hope that makes sense. If you have any questions, please email.